We are continuing with 12.2. I'm going to do that first example again because I didn't record it the first time around. We left off, we talked about the basic counting principle, multiply the two together, how if you're trying to figure out how many ways something can be rearranged, where order obviously matters, you would use permutations, which is the factorial of the number of items in that set. And if you take them a certain number at a time, then you're doing the factorial. So this one we did n factorial. This would have been n factorial over n minus r factorial. N is the number of items in a set, and r is how many you would take at a time. The factorial of permutation. We did this one, right? This was, the band has written 12 songs, plans to record 9 of them for a CD. So this is 12 factorial over 12 minus 9 factorial, which is 12 factorial over 3 factorial. And then we expanded that. That would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. And then we crossed through that, and then we multiplied out. And I said, ladies, for those of you that weren't here, I said you'll get to be able to use a scientific calculator for this stuff. So 10, 9, 8, 7, 6, 5, 4. So 79,833,600 different ways that you can rearrange those 9 songs, which seems ridiculous. Okay, and then we left off here. So for a town parade, you'll ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is the first and the float with the school chorus is the second. So we're trying to figure out the probability, right, that your first and chorus is second over the total number of combinations, right, which is going to be 14 factorial. So when I worked this out the first time, we actually figured out 14 factorial, but I don't know why I didn't think about it, but I wouldn't do that because we're going to eventually want to cancel out the factorial anyways, so you want to save yourself that time. So think about what happens if I'm saying, okay, if I'm the first float and the school chorus is the second float, how many other floats are left to figure out the combinations of? There's 12 left. Does that make sense? So I'm saying, okay, that would be, there's 12 possibilities because I already took the first 2 out of 14 possibilities. So this would break down, and this time the larger factorial is in the bottom. So this would be 14 times 13 times 12. And then these cancel, and I get 1 over 14 times 13, 14 times 13, which is 182. So by saying which 2 come first, we eliminate those 2 options, bringing it down to 12. There's another way to do this, which I think gets easier when we get into independent, which is going to come in sections 4 and 5. But for right now, we can stick to this. Okay, so find the number of ways, this kind of sums it all up. Find the number of ways that you can arrange the letters of the word boundary, and then 3 of the letters of the word. So if I just want to know how many ways I can rearrange the word boundary, what would I use? Good. There's 8 letters there, and it's just any order, so it would be 8 factorial. So again, try to find the exclamation mark on your calculator because you probably have one, and it makes your life a little bit easier. If you have a graphing calculator, you have to go to math, over to probability, and it's the 4th thing in the list. Yep. Second part. Oh. All right, so then it says, then 3 of the letters of the word picked at random, or in a different order. How many different orders? Okay, so this time we're pulling out the 3, right? So now we're introducing an R. So this would be the 8 factorial over the 8 minus 3 factorial. 8 factorial over 5 factorial. And this goes 8, 7, 6, 5 factorial over 5 factorial. Cancels, and then I would do this. 8 times 7, 56. 6, well, I'm just going to use my calculator. 6, 336. Good on that one? Okay, that's a 336. Okay, so then this notation is exactly the same. These are saying this is a permutation where the left side is your n, so this is my n is 6, and the right side is my r is 3. Okay, so I'm going to show you, obviously set it up the same way we just did without using the button on the calculator, and then some of you have it, and I'll show you where it is. So this would be 6 factorial over 6 minus 3 factorial, or 6 factorial over 3 factorial. 6 times 5 times 4 times 3 factorial over 3 factorial, and that's 120. So it's even easier when they give you the notation. There's no guesswork, okay? The P stands for permutation. The bigger number, which is always going to be on the left, is your N, and then the one on the right is your R. Okay, so now it's going to take like 17 minutes to do this because you all have different kinds of calculators. But if you find a button that says P and R, so when you click on the button, you have a P, you have an N, and an R here. So under a graphing calculator, it's going to be under your math menu. Math, go back to that probability list, and you'll see it there. Scientific with a PRB button, it's going to be there. You want it to be NPR, yep. We're going to get to NCR tomorrow, okay? So if it looks like that when you click it, then you put first the N. So first I would put the 14. Then I hit the NPR button, and then I hit the 9. I don't know if yours does it. If it doesn't have it, the 3, then you'll have to figure it out. That's the last one. Yeah, so you see it, right?
Yeah. Mine is
Yep.
above the 9.
So you will have to. All right, so that I am very clear, and I'm recording this so that I am very clear. So that I am very, very, very clear. Am I clear?
Yes.
When you have a question like this on your quiz or test, you are going to be writing out what it is. So you will write 14 factorial over 14 minus 9 factorial. And then from there, you may use your calculator. But I better see this. If you only use your calculator, oh, give me a break. I'll take away the calculators and it will be a lot less fun. Okay? You need to know how to do this because, to be honest, not all calculators have factorial buttons. Not all calculators have that NPR. Okay? All of them have multiplication, though. So all of them should be able to multiply the numbers out once you can reduce it from here. But you need to at least show me that step. Am I understood? Okay, also, if you accidentally write the wrong numbers in there, I can give you partial credit. If you just give me an answer with your graphing calculator or your scientific calculator and you have hit the wrong button and it's wrong, it's all the way wrong. Okay, so it's doing dual purpose. One, making me, showing me that you know what you're doing, and two, getting you the possibility of some partial credit.
And so what would you do, like on my calculator for the NPR?
So you're going to do, for yours, you're going to do the 14 first, and then hit that NPR button, and then hit the 9. If you have a newer, which I don't think any of us do, if you have the newer graphing calculators, when you hit that little button, it gives you a little subscript on either side where you can literally write in the 14 and the 9 so it looks just like it, but everybody else's, I think, is the other way. All right, let's do this last one. There are 8 students auditioning for the main role in a school play. The order of the student auditions is chosen at random. Find the probability that you are chosen first to audition and your friend Petra is chosen second. So important things to notice here. 1, the word probability. So I'm not just giving a single number this time, right? I'm saying how many over how many. And this is just like that float one. If there's 8 students, then the bottom is going to be 8 factorial. And then if I'm sticking me in the first spot and Petra in the second spot, how many other spots are there for me to figure out? 6. So this would be 6 factorial over 8 factorial, which becomes 6 over 8 times 7 times 6 factorial, or 1 over 56. Questions on any of the stuff we talked about today or yesterday? Okay, so this, remember, keep this word in your head. These are all permutations, and permutations are when you want to mess with the order, okay? Because tomorrow we get into combinations, which is similar but different, obviously.
Why is it a fraction